All right, so tools and supplies. All right, we're going to explain the safe use of all the different hand tools. Whether it's hand tools, power tools, we want to make sure that we're using them properly, we're using them safely. We're making sure that when we are working on things, we're using lockout, tagout. That's important. We're not going to lock out, tag out things that are energized if we're testing for electricity. That sort of defeats the purpose. But if we're working on mechanical things, we're always going to be doing that. So always keep those in mind. All right, so we're going to use proper use of thermometers, manometers, linear measuring tools, and meters. List of basic supplies required for most residential and commercial service. There's different tools that we're going to need to be able to do our jobs. Some stuff you may already have, some stuff you may have to purchase. Okay, list industry standard tools supplied by company to technicians. So there's going to be certain things that the company is going to provide to you that you don't have to go off and buy right away. All right, make sure the tools and equipment in poor condition can result in improper repairs and increased waste. All right, if your tools aren't functioning properly, you're not going to be able to do the job well. That's going to take more time. Your boss is going to get mad at you. He's going to scream at you. Make sure that your stuff is in good quality. All right, good condition. Wrenches. All right, we're going to use a wrench that's going to fit around a nut or a bolt. All right, we want to use the right size. We have standard, we have metric, we have combination, we have crescent wrenches, we have adjustable. I mean, there's all different types of wrenches that are out there. A lot of times, the go-to wrench for a lot of guys is just going to be the adjustable wrench or some channel locks. Channel lock's a brand name, but still, that's what we go by, or at least I do. And those are nice. The problem with the channel locks is that if you don't grab the head properly, you're going to start to round out that bolt. You're going to strip it. Then you're going to have difficulty removing it. So it's better to use a wrench that's made for a specific nut or a bolt. Whether it's a 6-point, 12-point, whatever the case may be, we want to grab that entire nut and without potentially stripping it. Okay. So we're going to use potentially sockets depending on the application. Okay, we're going to put the socket all the way on there. Let's just say we have a short socket. That short socket isn't going to go all the way on because we have a piece of threaded rod in our way. Well, let's get a longer socket. Let's get a deep socket that's going to fit over that. Or if we have nut drivers, get a hollow shaft nut driver. All right, that way I'm able to really get in there and make my life that much easier. You'll be surprised at how much you do use nut drivers. Nut drivers are used 70-80% of the time on equipment, taking panels off, taking panels back in. So we'll keep that in mind. All right, avoid pounding on a wrench to increase torque. Okay, if you start pounding on things, you're going to potentially snap something, especially if it's seized or rusted. So we want to make sure that we have a smooth, continuous force. Push or pull, depending on the application, where you're at, how you can get your wrench in. We want to make sure that we're applying nice, even pressure. If the wrench that you're using isn't large enough, well, get a bigger wrench. All right, use torque, or not torque, but leverage to really put some torque on that bolt to actually break it loose. PB blaster goes a long way too. Using PB blaster, let that sit for a little bit. If something's rusted, it'll penetrate into the rust, it'll break it apart and make your life that much easier. Okay, we want to make sure that our wrenches are good quality. I know that there's all kinds of different tools out there, but make sure you buy a name brand, something that does have a warranty, things that it's a good quality. I am happy with Craftsman. I know that their hand tools are okay, at least for what I do. I haven't had any problems. Snap-on, Matco, great products, but they also are a premium. I would stay away from things like Harbor Freight. Maybe their wrenches are going to be okay, but their power tools are complete garbage. All right, especially if you're going to be using drills and that sort of thing. It may last you only 2 weeks or 3 weeks. So invest your money wisely in certain things. Okay. When we're talking about wrenches, we want to make sure they have a good steel, heat treated, accurately machined. We don't want them to be jagged or uncomfortable to hold because we are using our hands. All right. Safety, always pull on a wrench rather than push. That's not necessarily the case. Okay. Sometimes we have to push just on the application we're in. We just can't get to the other side. So keep that in mind. Also keep in mind about bashing your knuckles. If you are pushing on something or pulling and there's a pipe in the way or something, maybe you're pushing with an open hand. So if you do, jolt forward, that nut does break, or maybe it shears off, you're not going to smash your knuckles, your hand. At least you're going to hit something with the palm of your hand. Okay. So we have different wrenches that are used in the HVACR industry. All right, complete set of both standard and metric wrenches. Depending on what you're working on, where you're at, it may be metric, it may be standard. There is no universal. There may be some international machinery that comes in, depending on if you're in the industrial sector or if you're in a commercial setting. Otherwise, it'll be standard. The big things that we come across, it's usually 1/4 inch and 5/16 screws. All right, they're going to have a nice little hexagonal shape to these screws, so we can actually put a nut driver on there. We can put different wrenches on there, open end. We can even use screwdrivers on these screws. So they give you a lot of versatility. 1/4 inch, 5/16, and then even 3/8 on some of the larger pieces of equipment. So that's going to be your most common size of screw that you're going to find. Okay. Make sure that you have versatility to be able to get different screws out of different applications. So socket wrenches, so it's a handle with a socket on one end, and it has a ratcheting motion that moves back and forth. It makes our lives much easier rather than making full rotations while holding on to one side of like an open end wrench or a box wrench. We can just quickly twist our wrist and we're able to back out our bolts or our nuts. They're really nice in tight places. You can put extensions on them to give you more leverage or length. So real versatile. I was actually using socket wrenches today to get under pieces of equipment. All right, the handle turns in one direction while turning the shaft. And then as we come backwards, there's a little clicking motion that resets the handle, and then we're able to pull or push depending on the application. We can then switch the direction that we're ratcheting. We can either put the bolt on or take it off. So this is just a little set. We've got our ratchet wrench right here. We've got the adjustment knob at the back. We've got our handle here. We'll grab it here and we'll be able to rotate it either clockwise or counterclockwise. If I need to get into a little bit of a deeper place, I have an extension. I can put my socket, which are these, onto the extension. My extension then goes onto my socket wrench, and I'm able to work. This is considered like a breaker bar. These are nice, especially if I need to put a little bit more torque on something's stuck in a tight place. I mean, this thing, the breaker bar is almost double the size of the socket wrench, so I'm going to get more leverage on it, and I'll be able to put more torque on the bolt, hopefully loosening it. 12-point sockets, they're nice. Depending on the application that you're working on, they give you versatility because you can actually spin them, just a tiny bit for that nut to grab inside here. And then if we have a 6-point nut, it'll grab on 6 different sides of that socket. But ideally, if we can, a 6-point socket's going to work better for us. Nut drivers. This is definitely something that you should get, and you will be using a lot of. All right. Basically what they are, they've got a size at the end of it. It's a hexagonal shape that's going to fit a nut or a bolt. And then Depending on the type that you have, there may be a hole that's drilled inside here. And those are nice because I can reach into deeper spots. So I'm not going to be obstructed by the rod before I get to the nut. All right, sometimes the nut's on there a little bit deeper than this little area would allow for. So make sure you get the hollow ones. Make sure you get the magnetic ones. The magnetic ones are a lifesaver. I bought some that weren't magnetic. Magnetic does help because I'm able to put that nut, that bolt, right in the tip. It's going to stay in place, and I can reach into my piece of equipment, screwing it in. These things are also color-coded usually, so that's always nice. You know, I can just look at the bottom of my nut driver, see that, hey, I need a red one. I pick up a red, and I know it's a 1/4 inch. Box end wrenches, this is what I was talking about, having a 6-point as opposed to 12 points, but they're both making contact across the nut evenly, and they're going to apply nice even force, all right, all the way across. Box end wrenches are nice when I can't put a socket wrench in there. They're not going to fit in, and then the box end is actually going to not potentially slip off the nut if I were working on it. Okay. Sometimes they come with a offset on them to get into different areas to make it easier to work on. And we just have a couple of combination wrenches. We have a opened end wrench, and then we have a combination wrench. The open end basically has the 2 gripping sides, whereas the combination has the box end on one side. So there's versatility with it. The open end is going to have 2 different sizes. So this one can do a 9/16 and a 5/8 bolt/head. Combination can do 11/16. All right, and then the box end is also going to do 11/16. The box end is usually a 12 point, so they don't come in 6-point, or at least I haven't seen one. Maybe they do, but usually it's 12 point, so don't be alarmed. And then we have other types of wrenches. All right, we have the adjustable, we have a pipe wrench, flare nut wrench, hex key, Torx, refrigeration service valve wrench, torque wrench. These are flare nut wrenches. These are nice because I'm able to really get some nice gripping strength around the flare nut. That's one nut that I don't want to strip or round out. The reason being is that's the flare nut's already sitting on the copper line, and in order for me to get that off, I would have to cut the copper line, and it just becomes a big headache. So if I am working on flares of some sort, or I'll use these. Okay. Pipe wrench, we're going to use the pipe wrench when we're talking about pipe. Usually when we're doing our gas lines, that sort of thing. Gas line is rounded out. There isn't a really great way of gripping it. So pipe wrenches are going to have these little jagged teeth on there to help grab the pipe. And so you're able to torque and grab the pipe properly. Sometimes you can use the channel locks, that it helps, but the pipe wrench definitely bites into the pipe much better. Hex key wrench, they're hexagonal. They're used to open up our refrigerant valves. They come in different sizes, different shapes. Torx wrench, it's got little stars on there, sort of looks like the hex key, but with little stars on it. And then we've got the refrigeration service valve wrench, which we also open up service valves, and we actually do a few things with that. And then the torque wrench, that's used for actual flare fittings. It sort of defeats the purpose of the flare nut wrench because I need to torque my flare nuts to a certain torque. How tight is tight? Well, I don't know. The torque wrench is going to tell me. So the manufacturer is going to specify that it needs to be 15 foot-pounds. Well, I set my torque wrench, I start to tighten. As I start to tighten, the torque wrench either beeps or makes a little click, and it tells me that I've reached the proper torque. If I were to over torque something, then there may be a potential for refrigerant to leak out, or if I didn't tighten it enough, well then we'll also have issues. So, you know, your arms may be bigger than mine, you may be stronger, so, you know, what you think is tight may not, or maybe too much. So a torque wrench, pivotal, or great piece of equipment, especially during mini split installation. Adjustable wrenches, so every tool should be kept in good condition, okay? Adjustable wrenches, I use those a lot. Rather than keeping combination wrenches in my bag, I can have 1, 2, 3, and they're going to really do the job for me. Okay. Hammers, usually we're not going to have a hammer like this in the HVAC sector. This is a hammer used for carpentry. We're going to be pounding in nails, we're going to be removing nails. All right, we've got the claw on the back side. If this is what you have, well then it will work, but if anything, we're going to have more of like a sheet metal type of hammer. That's going to look similar to this, except it's going to have a flat face on here, and then it's going to have sort of a long beveled shape at the end for bending and working with sheet metal into tight corners. All right, it's not going to have this gap in here for pulling out nails. All right, but anyways, the handle's attached to a hard head, and it's used for pounding or striking. Okay, hammers come in 12 or 16 ounce. They can come even heavier, but we're not doing a lot of pounding, so we don't need different types of, you know, sledgehammers or anything like that. A ball peen, you may or may not use this. They're nice because you can actually round out different things with the this side of the hammer as opposed to the flat side. So there's some versatility to it, but usually we're going to use a sheet metal hammer. There's mallets. If we're working on really large sheet metal, that sort of thing, we can use these to separate parts without damaging them. They come with either a rubberized head, or they have ball bearings that are inside there. That'd be referred to like a dead blow hammer. As soon as you hit something, those ball bearings sort of come to a stop and absorb all the force and the recoil. Okay. Other materials can be wood, plastic, lead, brass. There's all different types of different hammers out there for various applications. We just want to make sure that we're using one that's going to work well for us. Generally speaking, like a rubber hammer or a rubber mallet is a good one to have. It's sort of versatile. Whether you get a black head or a white head, that's up to you. I found that the white head just doesn't leave little black scuffs as much, so I would gear more towards the white one, but you know, depending on what you're working on, is going to dictate the type of hammer that you're going to need, or the mallet. All right, we have pliers. They're used for gripping or cutting. We have combination gripping pliers. So these off over here are considered slip joint pliers. I don't like these. I never liked them. They seem to never give me the torque, the leverage that I need. So yet again, I will just use my channel locks to grab onto stuff. I've got a couple of different sizes in my pack, and that gives me a lot of versatility to work on different things. We also have cutting pliers, which are linemen or diagonal pliers. Just being in the military, we called them dikes, diagonal cutters, and so I sort of stuck with that, so I call my diagonal pliers dikes. Lineman pliers, these are versatile. They can have multiple functions on them. First off is we're going to be able to cut with them. The second is if we're going to have two pieces of wire, we can actually make a mechanical bond between them. We're going to take the two pieces of wire and we're going to put the two pieces of wire into the head right here. We're going to twist the entire lineman in I would say a clockwise motion, and by doing so we're going to twist the two wires together to make a mechanical bond, and then we'll be able to put a wire nut on top of them. All right, we're not going to just stick wires into a wire nut, call it a day. twist the wire nut on. No, first off we make a mechanical bond, and the wire nut just secures that mechanical bond. These don't show it, but other linemen do have it. They have a little serration right here at the bottom, so when you do clamp down, it has sort of like this vice action going on here. And what that's used for, it's used for pulling fish tape through conduit. All right. Being in Illinois, we have tons of conduit, and we need to run wire through that conduit. Sometimes that fish tape is difficult to pull because it's made of metal, and it's getting stuck inside there, whatever the case may be. We can grab the metal fish tape, all right, not fiberglass, but metal, right here in this prong. If they allow it, I can clamp down with the handle, and then I can pull. And so I've got more of a nice grip, and I'm pulling with the tool rather than just using my hands or my fingers. And then there's different specialty pliers that are available. End cutting pliers, long nose pliers, duckbill pliers, needle nose pliers, slim nose, curved nose. Honestly, I use a pair of needle nose. Usually needle nose for me is the same as long nose. I'm really not seeing much of a difference between the duckbill and the long nose, but the duckbill is going to have sort of like a flatter shape towards the end. Okay. Needle nose, you should definitely have one of these pairs in your bag. There's going to be instances where you need to get in there in a tight little spot. They sort of act like tweezers, and they're able to put like a nut bolt on, something like that. You're not going to be doing anything technical with them as far as tightening little things up. There's other tools for that, but they're more like elongated tweezers. And then we have screwdrivers, all right, consist of a handle, shaft, and head with sized and shaped tip, used to turn screws. Okay, complete set is needed for installation, shop work. All right, screwdrivers, very critical. You want to make sure that you've got a good screwdriver. I like using the Klein Multi. It's got a bunch of different bits in there that I can just swap out, and all of a sudden I have another screwdriver. Instead of having 15 different screwdrivers in my bag, I keep swapping out bits, and I'm good to go. The nice thing about that too is that the Klein also doubles as a nut driver. Okay, so if I have a application where I need to work on something, I'm up on a ladder, I'll grab my multi screwdriver. I can work on different screws, bolts, that sort of thing, all with one tool, instead of having to carry 15 things in my pocket as I go up and down. All right. So we have different bit heads and types. All right. The keystone or the flathead, that's what I commonly refer to it as. Okay. You're going to see the flatheads a lot. I try not to use any screws that are flat-headed for installation or anything like that, just because they're a pain to use. Trying to use a cordless drill with a flat head is almost impossible. I don't know how the old-timers used to do it, but I'm going to use something that's going to be a little bit more forgiving, and so I'm going to go more towards the Phillips bit. Okay, so the Phillips bit is just sort of like a T-shape. Fits right in there, has a nice lot of torque to it, and I'm able to move that screw very well. Sometimes you're going to see screws that are a combination of the Phillip with the flat. Depending if you're running your drill or the screws sort of seized up, if there's too much torque coming from your drill, what's going to happen is this is going to jump out of the screw and thereby rounding out this area. And if this rounds out, now all of a sudden I can't get this Phillips bit to pull this screw back out. And so because of that, sometimes you may have a slotted area in there just in case that this gets rounded out. I can still use a flathead to pull it out. Clutch head, honestly I've never even seen this out in the field, so I'm just going to say that it doesn't even exist, but according to the book, it does. Allen, you're definitely going to see this. It's basically a little hexagonal shape, and what ends up happening is we have this little rod. It's a hexagonal shape. It fits directly inside here, and we're able to twist and pull, and or I'm sorry, not twist, pull, but loosen and tighten. These are actually really good. As long as you use the right size Allen, they're probably one of the best types of bolts that you can find. So a lot of the higher end companies out there, not in HVAC, but in general, will use these. Also, service valves are all going to be an Allen wrench or a hex bit, or just a couple of names for them. And then we've got the Bristol recess. Bristol sort of looks like a Torx, the only difference being it's got a little bit of a interesting shape. I'm not sure why they didn't show you a Torx, but these are just various applications and different heads. All right, a vise. Vices are critical. All right, you may have one, you may not have one, but they can be a lifesaver. It's a clamping apparatus. So basically what happens is we have a stationary section, which would be this one here on the right, and we have this section here that opens and closes via this leverage system here. As I turn this screw, we'll say clockwise, this vise will start to close, and anything that is in between these two heads will clamp down nice and tight. They're using these brass jaw caps to prevent any material that they're working on. All right, the brass is going to be softer than, let's just say, steel. It'll still hold the steel in place, but it won't damage or mar that product that we're working on. If I were to take them off, I have steel heads with some raised teeth that may leave an indentation. So keep that in mind if you're working on something. We're going to use a pipe vise for cut piping, cut tubing. All right, we can use it to hammer things out of. We can put bearings in. There's a lot of versatility. Anything that's going to be nice, solid, nice working surface, this is perfect for. All right. We also have drill bits. All right, it's vital to make holes in different applications. All right, we're going to use different types of drill bits for different applications. All right, we've got different bits for metal, wood, plastic, masonry. They can be turned by a drill press, portable electric drill, or cordless drill. We want to make sure that we know which type of drill bit we have for the application that we're in. A metal bit, it's going to look very similar to this. There's bits out there, they're called cobalt. They're designed for drilling through metal, very strong as opposed to like a black oxide or even a titanium. They're not as strong, and so they will burn out eventually. The cobalt, I seem to have really good luck with those, especially if I'm going to have to drill through like a stainless steel, or I've got a lot of metal, I'm definitely going to bust on my cobalt. This guy right here would probably be perfect for wood, plastic, masonry. If we're going into concrete or brick, that's going to be a different type of head on there, and that sort of has like a mallet head to it. It's sort of interesting looking. I'll try to pull one up here at the end of my video or before my video to show you what those look like. Okay. We have cutting edges of twist drill bits. All right, we've got the 120 to 135 chisel edge or angle. Honestly, this cutting lip is probably the most important and the most critical. Usually it's about 118 point angle. That seems to do the best from what I found. There's another bit out there that's a little bit more on the pointier side, but you just don't get as much material being moved out of there. The one thing you can do is you can look at the leading edge of your drill bit and see if it's dull. You'll start to see that you know, this right here starts to round out a little bit, and it just doesn't have that nice sharp edge anymore, and so you know it's time to replace your bit. There's drill bit sharpeners out there. They're sort of a gimmick. I wouldn't even waste my time with it. Just know that you're building this into the cost of doing business. All right, I'm going to replace my drill bit. We have different drill bit sizes. Okay, they're sized according to the hole that they're going to make. If I need to make a 1/2 inch hole, I'm going to use a 1/2 inch drill bit. Okay, they come in fractional sizes. So if I need a 3/16, I can find a 3/16 drill bit. Okay, they're numbered from number 1 to number 80 in sets, and they can have letter sizes from A to Z. We also have tap drills. All right, they're slightly larger than the inside diameter of the threads, and they refer to the tap drill size table. So basically, if I'm going to put threads into something, I need to be able to drill a hole, and once I'm able to drill that hole, I can put in a tap drill, and basically what that's going to do, it's going to create the threads inside of a piece of metal for me. But I can't just put that tap drill in. I need a hole there to begin with first. So this is just an indicator of how a tap drill works. All right, so this is the area that I just removed, okay? And my tap drill is going to come in, and it's going to remove these little V shapes here for my screw to go into. If I drill too large of an area, I don't have as deep of these little V-notched areas, and my screw isn't going to hold very well. All right, if it's too small, well, then my drill or my tap isn't going to go in. I'm going to have issues. I may even break my tap. So we want to make sure that if we're using a tap, that we use a corresponding drill bit size for it. Okay. Be sure to keep the head of the chisel free from mushrooming. Okay. We want to make sure that we're not mushrooming anything. So, for example, if I were to hit a threaded rod, okay, threaded rod is, just think of it as the bottom end of a screw, okay, and there are applications where I have just this threaded, literally a rod, and there is no head to it, and I need to hammer it or put some force to it. What'll happen is if I start to hammer at the end of it, it'll actually start to make a mushroom shape to it. And the downside to that is now all of a sudden that nut that's on my threaded rod won't be able to come off, or I won't be able to put a nut on. So a little trick for you guys is you take that nut that's on there, or going to be on there, and you put it all the way up to the top, all right? And you go just a little bit past. So that way I'm actually hammering on the nut as opposed to the threads, and that way my threads will still maintain their shape and I won't mushroom out anything. We also have punches. All right, punches are used for making marks. They're used for making holes and driving out pins. Okay. We can also have a center punch, drift punch, pin punch, prick punch. The center punch, we're going to use that as a little indentation. So if we're drilling on through a piece of metal, and we put our drill bit on that piece of metal, we may find that our drill bit likes to walk, or it doesn't like to stay straight, and we're trying to drill something precise. Well, I'll take my center punch, I'll put that directly over the point of where I want to drill. I'll take a hammer and I'll lightly tap on that center punch, and it'll make a little indentation, and that indentation is just enough for my little drill bit to start to grab and start to cut that hole. Okay. Pin punch, if we run into different pins that are that need to be driven out, the pin punch can help with that. So the shafts come in different sizes. One example would be like door hinges. If we want to remove the pin out of our door hinge, we could use a little pin punch, the same diameter as the pin that's inside there, and we're going to remove it. The drift punch, there may be different applications that you may use that. You're just trying to hit something, whack it out, get it out of the way. The prick punch, it's a little bit more precise type of thing. We're just trying to really make something a little small, little nick. All right, it's a really fine-tipped unit, and I don't want to use anything on there like making a mark for like a center punch or anything like that. If I hit too hard, then I'll damage this tip. All right, yet again, safety. Always make sure you wear safety goggles or face shield when working with chisels or punches. We have files, all right, used to clean and shape metal parts. You can use this on plastic, you can use this on wood, you can use this wherever you want, but mostly it's metal. All right, what ends up happening is we've got these little teeth that are in here, and as we push across a metallic object, these teeth are going to grab onto any of the metal, and it's going to start to shave off the metal. Okay, we can have single cut files, meaning that they're going to go in one direction, and the double cut file means that we're going to remove material in both directions. So on a single cut, it may be a push method we're removing material. On a double cut, it'll be a push and a pull. Okay, these can have teeth all the way around, so you can use all four sides of it if needed. They come in different shapes as well, depending on the application. We have the traditional rectangular, then we have the round, we have a half round, we have a square. Depending on what you're working in, different file for different applications. Hacksaws used to cut tubing and other metal parts. Nope, I don't agree with that. The reason being, a hacksaw, it's a metallic blade, usually 18 inches or 18 teeth per inch. It can be 14, 24, or 32, just depending on what you're working on. The problem with the hacksaw is you have to be extremely precise if we're cutting any type of copper to use for our reconnection. So if my hand is not perfectly perpendicular to the copper as I'm cutting through, I'm going to have an uneven cut. And do you know how many times that's going to happen? Probably 99% of the time. So if you need to, hacksaw is a nice quick tool to get in, cut something soft. But I usually try to stay away from this guy. I'm going to use a tubing cutter to cut my copper. Okay. Directional blades must be installed properly. Absolutely. There's a way you put the blades in. Follow the recommendations. Usually it's on the pushing stroke that you're going to cut with the hacksaw, all right, as opposed to the pulling. So we have levels, all right, used for neat and proper installation. We want everything to look pretty, nice, and equal to the eye. Okay, we're going to make lines perfectly horizontal, or we're going to make them perfectly vertical. We have different bubbles. Okay, we've got the plumb bubble, so depending on the shape and the orientation, it's going to tell me if my my object is perfectly up and down. My level is going to say great, I am horizontal, and then I have a 45-degree bubble on here as well. The nice thing about this guy right here too is it's got two lines, and the two lines indicate whether or not there's a pitch. So there'll be sometimes where you have to incorporate a certain amount of pitch into your into the work. So let's just say we're working on a high efficiency furnace. We have plastic or PVC piping. The PVC piping has water that condenses inside of it. That has to be pitched properly. We then take the level, we put it onto the PVC, and we slowly lower one side until this bubble moves over and it starts to touch this line, the second line. Once it starts touching the second line, I now have a 1/4 inch per foot drop on my pipe. And so now I've got a nice angular flow, and water is going to want to run perfectly down through that pipe in the direction that I want. Power tools, awesome stuff. You're definitely going to be investing in power tools. At first, you're going to get probably a drill and maybe an impact driver, maybe a little cordless screw gun, something along those lines, but they make your lives that much easier. Okay, there's definitely numerous types, all for different tasks, just depending on what you're trying to achieve. Be careful when you're using them. They do have blades, they have spinning things. They can be sharp, so we want to be aware of what we're cutting, what we're doing with them. Make sure we're aware of our surroundings. All right, so. All right, electric drill should be grounded for safety. Everything should be grounded for safety. All right, if you have 3 prongs on your drill and that third prong is broken off because it just doesn't fit or whatever the case may be, fix it. All right, you can buy a replacement head for your drill just at the store. You know, you just want to redo the power cord for it. Make sure that you have that ground. Okay, some tools are naturally insulated from electricity, other tools aren't, so we want to make sure that, you know, we are protected. A lot of times now, and we're using cordless tools, so we're not going to have to worry about that ground prong. Some tools don't even come with it, so, but if it is an option, use it. Yet again, make sure you wear safety glasses. Things do fly up and can potentially hit your eye. If something hits your eye, you may lose it. So it doesn't hurt just to wear a good set of eye protection. All right, we have also instruments used to determine conditions inside a refrigeration system. So thermometers and pressure gauges. They must be handled carefully and kept in good condition. Good thermometer, we want to read what our temperature is in the environment that we're working in. It's going to indicate whether there's a problem or no problem in that area. Same thing with our pressure gauges. You know, if we have a good set of pressure gauges, it's going to tell us a lot about what's really happening in the environment that we're working in, right? If our pressure gauges aren't working, it's time to replace them. You can replace the gauges individually, or you can replace the entire manifold set. But know that you can repair a lot of things if needed. So thermometers, there's different types out there. Glass stem, we're not going to use that. Dial stem, you're probably not going to use those. The glass stems are what we used back in the day. You know, some of you younger guys may not have used them, but you know, if you were sick, guess what? You get a glass thermometer. Make sure you don't bite down on it. All right. We also have the analog and the digital. Digital is pretty much what everybody's going to be using. All right. It's nice. It's simple. It's going to give you a little readout on an electronic screen, and it's going to tell you what the temperature is. All right. Temperature probes. A lot of your multimeters actually come with the capability of being able to read temperature, so that's a nice thing as well. Infrared thermometers. We're going to shoot a laser at an object, and that laser is going to come back and it's going to tell us what our temperature is. Really cool for high ceilings, areas that we can't get to. I'm going to shoot that thermometer. It's going to give me a reading. The only problem with the infrareds is that they don't give you a precise reading. So if you're looking for precise, don't use it. If you're looking for a little range, the infrared could be off by 2 to 5 degrees. If I'm checking for something that's going to be 700 degrees, well, 2 to 5 degrees isn't going to matter. But if I'm checking, you know, to see if I have a 1 to 2 degree difference, that just may be, you know, too close to tell to use with the infrared. The other issue that you're going to have is that they're not going to give you a precise reading on shiny objects. So if we're trying to shoot some sheet metal or anything like that, you may not get a proper reading on those. So just keep that in mind. Okay, and we have recording thermometers, which are just going to measure the temperature over a given time. All right. Extreme care should be used when using thermometers that contain mercury. All right, if you find mercury thermometer, let me know, because I've Really never seen a mercury thermometer. I have seen mercury in thermostats, and so those are still prevalent, but a mercury thermometer, not so much. All right, but understand that mercury is highly toxic. It can cause poisoning as a liquid and in vapor form. We also have manometers. Okay, they're the pressure gauge used to measure values around atmospheric pressure. Okay, we're going to use our manometers to measure our gas pressure. We're going to use them to measure the air pressure inside of our ductwork. We're going to see, how much air is really flowing through there. The tools that we're going to be using a lot of. Okay, they're going to tell us what's going on. It's like measuring the blood pressure of the system. Right, testing our static pressure is going to tell us where we stand and what adjustments we need to really make. Same thing if we're adjusting our gas pressure on our furnace. We want to make sure that that gas pressure coming in is within the manufacturer's specifications. We're getting the right amount of gas coming in for a proper combustion process. And so we need the manometer to tell us that. Tape measure, we've covered this in one of the previous classes, but be knowledgeable of how to use a tape measure. Okay, you're going to be making cuts doing sheet metal installation, tubing, piping, whatever the case may be. We want to be able to read the tape measure and know how to use it. So micrometers, you may or may not get into using micrometers, but they're there and just a very precise way of measuring things. Multimeters, having a good multimeter is actually good. Most of the time when we're doing repairs or service work on equipment, we're going to be testing electronics, and so we need a good multimeter to tell us exactly what's going on with that system. All right, electricity is vital to a lot of these applications, and being off by say 10 or 15 volts can play pivotal to certain pieces of equipment. So the multimeter is going to tell you your voltage, your resistance, your currents, various others. We're going to test capacitors from them. Amps, you can test diodes, you can do the temperature like we were saying before. We've got our probes that would click into the bottom, and depending on the function that I'm trying to achieve, I would put them in different settings. So for example, I can test my temperature here, I can test my my resistance and my voltage and my capacitance off of this guy. And then this is my common port. So I have two leads that would come out of this guy. One goes to one side of the unit, the other goes to the other side, whatever I'm testing. But regardless, good to have. They come in analog and digital. Yet again, good luck with the analog. Everything is digital nowadays. So, go that route. Couple of good brands. UEI makes a good one. Field Piece makes a good one. And then the top of the line is Fluke. You can never go wrong with Fluke, but they are a little bit on the pricier side. Most entry-level technicians are going to stick with like a UEI. Gives you a lot of versatility. It's an okay meter. Great for beginners and without having to break the bank. And then standard supplies, things that you're going to be using on a regular basis, things that you're going to have on your van, screws, bolts, fasteners, gaskets, abrasive brushes, cleaning solvents. These are all materials that are available, and they're just going to be used on a natural day-to-day usage. They can also have gloves. You can have booties, like little shoe covers for walking into a customer's home. I mean, the list can go on and on, just depending on what your employer decides to put on your truck. But those are all supplies that should be provided to you by your employer. You shouldn't have to buy screws or bolts or anything like that. Wire nuts, that sort of thing. Fastening method, we have a permanent way. We can rivet, we can weld, we can solder, we can braze. And then we have the removable, which are the nuts and bolts, cap screws, machine screws, set screws. For our applications, brazing or soldering is going to be the most prevalent. We're going to be brazing our refrigerant lines together, or if we're working on a water heater, we're going to solder them. Brazing is just a higher temperature, stronger weld, we'll say, onto copper. Welding, you may do that if you get into the pipe fitters or something like that, and we're making gas connections. You would want to weld a large pipe together to really prevent it from leaking. Riveting, that's just a application for joining two pieces of metal together using sort of like a compression type of nut that just won't let go. The only way to remove a rivet is you would have to drill it out. Okay. Otherwise, we have screws with nuts and bolts. Machine screws, they're a hybrid between a screw and a bolt. All right. There's different types of sizes. There's also different types of threads per inch. So, for example, we would talk about a 1/4 inch. Okay, so that is roughly the size of the shaft of the bolt. The diameter here is exactly what it would be. 1 divided by 4 is going to give you a 0.25. But then I can have either a 1/4 20 or I can have a 1/4 28. The difference being I'm going to have either a coarse or a fine head, which means that I have more threads per inch in a 28 than I do a 20. Most of the time, a 1/4 20 is going to be your nut or bolt of choice, but there are applications where the manufacturer, somebody decides that a fine threaded nut or bolt is required, so you're going to have that out there. So if you try to put a nut or a screw into a threaded fitting and it turns maybe once or twice and then it stops, usually it's an indicator that it's not the right thread for that application. So you may need to go with a fine or a coarse head just to make that work. It may even be metric. So there are times where I've run across different things like that and it's not the right size. There's little kits out there in tap and die kits. There's a little thread gauge on there. You can use a thread gauge. It'll tell you how many threads I have per inch, and usually from there I can figure it out. So for example, if I were to take a bolt and I measured 20 threads per inch, well, I know it's a 1/4 20 because nothing else is really going to have the 20 with it. Everything really stays comparative to whatever fractional size that we have. So if I went and I measured a 24 threads per inch, well, it could be a 5/16 or it could be a 3/8. So that narrows it down. I then measure my diameter and I'll see that, oh, it's closer to a 5/16 than it is a 3/8. And I know that it's going to be a 5/16 24. So, all right. Bolts, narrow threaded shaft with a head on one end, screws together with a nut, cap screw, threaded into part of a mechanism, does not require a nut. Okay. You can use a bolt to into a mechanism. The bolt, generally they tend to be much larger in size. Cap screw tends to be much smaller. All right, soak threads with penetrating oil if we want to remove them. That's what I was talking about, that PB blaster. PB blaster does work wonders. Otherwise, you can heat a bolt or nut with propane or an acetylene torch. The heated part will expand. Make sure the heated part is free of lubricants, and never heat vessel filled with gas or liquid. Okay. Lightly tap nut or bolt with hammer or mallet. Another little trick too is if you're going to be encountering a lot of rusted out or seized nuts and bolts, you can take some, I think, is it paraffin wax, and you can heat up the bolt area, and as that area, starts to expand from that heat, the wax, you just put it right on there, it'll get sucked right in between the threads of the nut and the screw, it'll actually act as a lubricant. It'll help break it loose. So just another little trick to use if you run into a little bit of a jam. You can use the wax. Gaskets, they're used between mating surfaces for a leak-proof joint, conform to surface irregularities, prevent refrigerant and oil leaks, keep air out of the system. All right, must not restrict openings within a system. I need to make sure if I'm going to put a gasket on something that it lines perfectly with all the holes. All right, I can't just flip this guy around and expect it to work. Okay, when we have two pieces of metal, they may not have the same surfaces that are going to be perfectly aligned. If we were to try to screw them together and try to hold liquid or gas in between them. And so what we need to use a little bit of a filler like this, the gasket. That's going to help keep all those impurities even. The impurities sort of mesh into the gasket. It sort of flattens everything out, makes it all nice and neat, and so that anything that were to leak out can't anymore. All right, we also have abrasive used to clean smooth or form metals to accurate size. So basically we have sandpaper, emery cloth, silicone carbide, aluminum oxides. If we're cleaning, for example, copper to make it nice and shiny when we're going to solder it together, we'll use a little bit of emery cloth. Emery cloth is just a small, thin strip of sandpaper that's really easy to get around and clean copper. Sandpaper is just a piece of paper with some adhesive on there, and literally sand is sprinkled onto it to create an abrasive surface. There's different types of abrasives that we can use, which are the silicon carbide or the aluminum oxides, and depending on the application, they're going to remove different types of material. We also have brushes that can clean copper or remove oxidation. Okay, it prepares metals for welding or brazing. So we have a cylindrical brush over here. We would insert that into a copper fitting. We would clean the inside of that copper fitting. We would then take the copper that's getting ready to be soldered. We put that inside here or here. This one can do either 1/2 inch or 3/4. We then twist this around a few times, and voila, we get a nice piece of clean copper that'll go into the fitting, which will allow for a nice clean soldering or brazing. Okay. We also have solder flux brushes. If we're sweating copper, we need to make sure that we're using flux. We're using flux to keep any impurities out from contaminating the copper, from bonding the two surfaces together. So we apply this flux on before we apply heat, and we apply solder, and it makes sure that everything's good to go. So we use the brush for that. We also can use paint brushes for removing dust or dirt, and apply cleaning paste. Different cleaning solvents: steam, caustic solution, mineral spirits, alcohol, degreasing vapor, cleaning fluids. Depending on what you're working on, there's going to be a variety of different solutions, chemicals that you can use for cleaning things. The caustic is sort of like an acidic solution. Like if we're cleaning outdoor condensers, there can be tons of dirt, debris, that sort of thing that's on there, and we want to make sure that that gets nice and clean, so we use a coil cleaner on there. It breaks down all the gunk that's inside there, leaving behind a nice clean surface. The only caution I emphasize on that is that we want to make sure that we don't use the coil cleaner every year. The reason being is it is an acid. It will eat away at the fins of your condenser, and eventually we will deteriorate the lifespan of that unit. So it almost acts as like dog urine. Dog urine does the same thing. It eats away at the aluminum fins, and your system no longer works properly because it can't release the heat like it's supposed to. All right. Just a couple of other stuff out there. Gasoline, don't use it. Don't use carbon tetrachloride. Or be careful when you are using it. Make sure that you're wearing proper PPE, that sort of thing. So then the employer is going to provide you a bunch of tools that you'll have access to. There'll be certain things that you need to provide, but when you show up, expect that there should be a truck available for you. If this is your first day on the job, they're not going to put you in a truck. You may ride along in a truck, but getting into a truck, you need to be well versed, show competence in your field to be able to go and do work on your own. But outside of what else you can find in the truck, you can find a vacuum pump, your recovery, recycling unit, tubing, piping, soldering, brazing, welding, all that sort of stuff, replacement parts, materials, leak detectors, electrical testing instruments. If we have like a megger, something like that, if we're talking about the windings of a motor, we're testing it, you may not have to purchase that, but your employer will. So the basic tools that we just talked about, hand tool wise, drill wise, that sort of thing, you will have to provide, as being an employee. And that's it for the slides. So before I pull up that video, do you guys have any questions or anything? No? All right. So I know that was a little bit of a long chapter for the tools, but this one's not too bad, this video. So right now we're on chapter 7 and we're covering tools. So I'm going to go over some of the tools that I carry in my van, and that's going to really help you guys out. There's all kinds of cool stuff out there. I like to be ahead of the curve, make my job a little bit easier. You don't have to go out and spend the money, but it's cool to see exactly what's out there. So let me go ahead and show you what we got. All right, guys, so I've got my little setup right here. Almost looks like a yard sale, but it's really not. So my first tool that we're going to cover is the oxyacetylene set. Really cool little setup, great for brazing. I prefer this over the other torch. Reason being is it gets a lot hotter. You have to be careful when you are brazing with the oxyacetylene kit, just because the torch does get so much hotter, it will start to melt the copper, unlike the premixed gas. So you do have to be careful, but it is nice to get the job done. It's a little bit on the heavy side, but so is the other tank. You can replace one tank. You don't have to get two. So once one empties, just replace the other one. You're good to go. So next what you have is the micron gauge here. It's a JB Supernova. I like this guy. You guys, some of you may already use this in class. Really nice setup, really accurate. It's really served me well. So attached to it, we've got our JB 5 CFM pump. I prefer JB pumps, vacuum pumps. You guys may find something, I'm sorry, it's a 6 CFM. You may find that you like something else. You may find that you like a Yellow Jacket or a Navic or whatever else suits you. But for my personal preference, I prefer the JB. I do have the Platinum, but it needs a little bit of repairs. Moving on over to our next little item here. This is just a little standard fan blade puller slash bearing puller. Really nice for those stuck on shaft items. So that'll go ahead and that'll break that for you. Moving on to this little beast here, we've got the Testo 310, and what this is, it's a combustion analyzer. So the way it works is we're going to go ahead, we're going to take our probe, we're going to drill a hole in the flue. We're going to insert the probe into the flue, and it's going to start to analyze the gases that are coming out of the combustion process. Those gases then are going to tell us what's going on with our system. Is our system running correctly? Is it not? Is there a potential crack in the flue? Is our flue plugged up? A lot of cool things that you can do with that. So it's a really nice tool to have. A lot of people don't use it, but it is becoming more and more popular. And then we do have a little printer here that attaches to it so you can print out your results, show them to the customer. Moving on over, I've got my little Hillmore bender here. Really cool setup. We're going to be bending copper. We want to make nice sweeping transitions. We're trying to avoid elbows, any points that we're going to add as far as connections go. So the less brazing that we do, the more efficient, well, not necessarily more efficient, but the less likely we're going to have a leak in the system. So this is a nice little tool. It's a ratcheting bender. So you put your copper piping right across here. This little mechanism starts to ratchet forward, and as it starts to ratchet forward, it goes ahead and starts putting a bend in that copper. Real nice tool to have, make those nice sweeping transitions or make that copper flow. Comes in different sizes. I got the 1/2 inch set up right there. We can go all the way up to 7/8 on this current setup. Cool thing about this guy too, and why I like it, is you can do a reverse bend, which means is the handle stays the same, but instead of the ratcheting going in this direction, we reverse it. So if we have a really tight area or against the wall, we need to make a bend, we put the reverse attachment on there, and now all of a sudden we're bending. Moving in on to the next guy, we've got our little swaging slash flaring tool. So all we do with this guy is we put our copper tubing right up through this little hole, or depending on whichever size we have. There's a little stop that tells us exactly where we need to be with our the depth of the piping. We spin our tool down until we make our flare or swage, and we're done. So nice little tool to have if you're going to be doing a lot of swaging, a lot of flare fittings. You definitely need something along those lines. For me, if I am going to be doing some swaging, I've got the hydraulic swager, so I use this guy mostly for flaring. Swage, this is the compact swaging tool, hydraulic. Awesome setup. All you do is you just put this little nipple right there inside the pipe, press it a few times, it expands, creates a beautiful little swage for you. Perfect every single time. Much faster, easier to do than trying to use that guy. All right, moving down the line here a little bit. I've got my little Yellow Jacket digital torque wrench. If you're going to be working on mini splits, installing them, servicing them, that sort of thing, it's very critical to torque the nut down on the flare nut to the manufacturer specifications. If you don't, you will leak. I had one that was sort of like the clicking type that a lot of mechanics use. It failed on me, almost caused a major disaster, so went ahead and purchased this guy. Nice digital setup, awesome. Moving on down the line here, next guy we've got our infrared thermometer. We're going to have registers, we're going to have vents, things that we can't get to, so this guy's perfect. We just shoot our little laser and it gets us a little readout of what our temperature is. Cool thing is I can put a little probe at the top here, attach that to my line, or attach the probe to whatever else I need to. It's going to give me a reading as well. Really cool setup. It's not 100% accurate, but it's very close. So within a degree or two, that should get us in the ballpark for most things. ECM tester, just got this. A lot of the new equipment coming out, or actually all the new equipment coming out, is an ECM type of motor. We're getting rid of the PSC. Reason being, the government mandated a more energy efficient type of motor that's going to be in your furnaces, so we need to be able to test it. There is no easy way to test it like we did beforehand with our multimeters on the old motors, where we put our 2 leads on some one on a ground, one on the lead, and that'll give us a voltage. Not quite as simple. You would either have to jump out certain pins, knowing which pins to jump out. You know, it can be something tricky if you're not doing it all the time, or you can just get the ECM tester, plug it in, it'll tell you if the motor's good or not. So basically we're saying a lot more electronics are involved in these motors that are really coming around. Moving on over, I've got my anemometer, and what this guy does is it's going to measure the airflow coming out of the registers and the vents. So we want to make, see what our CFM is, make sure that we've got adequate airflow coming out of there. Great little tool to have. Now we've got my digital multimeter. I like the Fluke brand. I've used them for a long time. This guy is going to measure your amperage. All you do is open up the jaws, put it around the wire, and it'll tell you what your amp draw is. If you don't want to measure amp draw, you can also measure regular voltage. Our little leads pop in at the bottom, and we can use it just like a standard multimeter. It doesn't have all the functions that you would need for HVAC with this model. So I know UEI does have like an all-invasive unit, but I do like the overall function and usability on this guy. And unfortunately, I do have to carry 2 meters, but it's worth it for me. Moving on down the line, we've got our combustible gas leak detector. So if we have a gas leak somewhere, I can use either soap bubbles, or I can bust this guy out, and what he's going to do is he's going to signal once we start finding a gas leak, and that little buzzing, the beeping sound that you hear is going to start buzzing really fast once we find something that's leaking. Really nice, just to start pinpointing leaks if you do smell something. Next, we've got the Rattler T40. This is a carbon monoxide detector. It's a little personal unit that you wear on your person. Critical to have this. A lot of people negate the fact that, hey, I'm going into a home, there may be a potential carbon monoxide leak, and you're just going to walk into the environment. Carbon monoxide is tasteless, it's odorless, and it will kill you. So whenever I'm working on furnaces, anything combustible, I do put this guy on and wear it just to ensure my safety. I had a home that I walked into, the flue pipe, it was a 6-inch flue pipe, and it had about a 4-inch hole in the side of it. So all that carbon monoxide was just leaking into the home. Luckily the furnace wasn't running at the time, so my meter wasn't going off, but had I had it on, I guarantee you it would have been sensing that, and would have saved my life if there was an issue down in the basement. All right, next little guy we've got is our digital manometer, and what this guy is going to do, it's going to read our pressures. We're not talking about high pressures, we're talking about low pressures. So if we get in really tight there, we're talking about inches in the water column. All right, so what I'm going to be testing is I'm going to be testing my gas pressure. I'm going to adjust my gas pressure, feeding the system, make sure that it's within manufacturer specifications. I'm also going to be testing static pressure. So in my ductwork, I'm going to see if I have any restrictions, airflow issues, that sort of thing. That's what this guy is going to point out for me. Right above it is just my little inspection mirror. When I'm brazing, sometimes it's difficult to get to certain areas. So what you need to do is you need to be able to use this little mirror, look underneath the bottom, look around, see exactly what's going on. So that's what we have there. Next little setup we have is our actual leak detector. This is a cool little dude right here. Use this a lot. It's going to detect refrigerant flow, or refrigerant leaks, I should say. So if you have a little pinhole leak, you're leaking from Schrader cores or anywhere else in the system, it may be difficult to see where that leak is coming from. Sometimes if you have a leak, we'll have oil coming out of that leak, which will it'll sort of oil up the side of the unit or wherever the leak is at, and so then we see that little sheen and we know that we have a leak. Otherwise, if we don't, it's a small leak, we may not have that oil. So this is where the leak detector comes into play. It's a little sniffer, sniffs up the gas into real small quantities, real accurate, works really well. Something that a lot of guys don't use. Yet again, a lot of these tools start to add up in cost, so it's not something you could go out and buy all at once, you know, unless you do have the funds. Great, but certain things you pick up over time and you learn what's going to work out best for you. Right above it, we've got our core removal tool. The way this guy works is we're going to go ahead and we're going to screw this on where our hoses go. We're going to go ahead and we're going to take this bad boy right here. We're going to start to unscrew this, and what we're going to do, if I can do this simultaneously, we're going to pull out the valve core that's inside our setup there. Once that valve core is pulled out, we're going to go ahead, we're going to close off. It's a little bit difficult to do one-handed here. We're going to close off the valve. Now our refrigerant can't escape, and we can unscrew it, and our valve core would be stuck in here. And so we would have two pieces. I then put my new valve core in, stick it inside, and do the process in reverse. So that's how we would go ahead and we would replace a valve core if we needed to. When we're pulling a vacuum, usually you want to remove the valve cores to help with the drawing of the vacuum out of the system. Got my Milwaukee tools right here. Just a few basic guys right here. I love my little drill. Works really well. I prefer the fuel type. The fuel is a little bit more of a heavy duty type of setup that you have. I've left this guy up on a roof through a rainstorm and it's worked perfectly fine. So really heavy duty tools. I would prefer that if you do get a setup and you get into the industry, buy something with a reputable brand name, Milwaukee, DeWalt, Makita, whatever else that you feel fit that's going to work for your needs. Stay away from the cheap tools. They do have a tendency to not last as long, and especially with the work that we're doing, we want something that's going to be pretty powerful and work for us. Things I like about the Milwaukee setup here, the tools have batteries that are interchangeable amongst them. I have an 18 volt and I have a 12 volt. I use 12 volt all day long, plenty of power for me. When I really need the oomph to do some things, I use the 18. So this is my go-to guy, a little 12 volt screwdriver. This guy I use 90% of the time. It will drive screws, it will do all kinds of things that the big boy does, but it's a fraction of the size and the weight. Over here we've got the tubing cutter. Really cool setup if you're gonna be doing a lot of tubing, cutting. Automatically does it for you. Super fast, efficient. Takes a little bit of getting used to, but once you get that down, you're flying through cutting, piping. Got a little sawzall here. Got the extended blade on here. I was cutting some 3-inch piping, PVC piping, so that's why we got the big guy on there. But plenty of power. Nice little setup to have. All right, and here is probably my favorite tool. This is the M12 Force Logic. What this is called a Pro Press. Instead of sweating pipe when we're doing plumbing connections, we have a little coupling. The jaws just go on the coupling. Once the pipe is inside the coupling, we press the button. The jaw starts to compress, and they go ahead and make a solid connection. I use this for refrigeration as well. It's called Zoom Lock. That's the brand name from Parker. They have Zoom Lock fittings, and you use these fittings with refrigeration. I don't braze anymore as much as I miss the torch. I really don't. You have issues when you are brazing. You can set things on fire, obviously. Sometimes if you're too close to a smoke detector, that'll go off. You don't have to nitrogen purge the lines anymore. All you do is clean up the pipe really well. Go ahead, put that on, crimp both sides of your fitting, and you're done. Real simple process. The fittings are a little on the pricier side, but it makes a world of difference. So that's what I've got here for the table. Let's move on here to the van really quick. So everybody's gonna have or need a good pair of gauges. These are my backups, just some JB gauges, 3 hose setup here. Gets the job done in case my primary gauges fail. These are my primary ones, the S-Man 460. These are awesome. I really love them. Digital gauges are the way to go if you can afford them. Really nice setup here. So I've got my low side hose, got my high side hose, and then my just a refrigerant line. My hoses are backwards right now just because I had lost a depressor in one of them, so I just switched the hoses since I don't use the refrigeration as much. So that's my thing, but I'll fix it eventually. But either way, my display basically tells me all my information that I need. So right now I have it set to R22, which is my refrigerant. It'll tell me my low side, my high side pressures at the same time, just like my other set of gauges. It'll tell me my superheat. So how do I know what my superheat is? Easy. I got my little clamps. Take my clamp, put it on my suction side, let it sit for a couple of minutes, and it's going to read what the temperature is, and it's going to tell me exactly what my superheat is. I don't need a chart with this guy because it's going to tell me what my saturation temperature is right here underneath it. It's even going to tell me what my line temperature is here. So we're obviously going to go ahead, we're going to take the suction line temperature versus the saturation temperature, and we're going to combine them, or the difference, and boom, there's our superheat. Subcooling, opposite side here, liquid saturation temperature versus the liquid line temp, 19 degrees. So technically I've got 19 degrees of subcooling in the lines. I am reading pressure right now in my hoses because I do have refrigerant in there. So more than likely it's R22 that's still been trapped inside. So we'll just leave that in there for now. It's not causing any harm. All right, moving on to this guy. We've got our recovery pump. I use the Appian. Really nice system. Removes all the refrigerant really well. Probably one of the better recovery machines out there. And finally, I've got my Klein tool bag. The nice thing about the Klein is it just holds all my little tools in here. So just starting off with the back side, we've got electric screwdrivers. They're insulated, so if I do touch anything on them, as far as me touching metal, I'm not going to go ahead and I'm not going to electrocute myself because they are insulated and they're good till 600 volts. I have another screwdriver in here. I've got a little tiny flathead used generally for control wiring, that sort of thing. A little larger flathead in here. This is my go-to prying, chipping, whatever I need. A flathead. That's my little guy. Does the damage as needed. Got a little channel locks, a little Sharpie, missing the cap, but pencil's nice to have. We don't want to mark certain things, so I got a little eraser on there too. Got a small little adjustable wrench. Got some channel locks there. Lineman pliers. So some diagonal cutters, wire cutters, whatever you want to call them. We got some needle nose pliers, wire strippers, We've got a larger adjustable wrench right there. Smaller, if I can get them out, set of wire strippers. You know, we're going to be dealing with some small wires, so this is nice to have sometimes. And your pack could be a little bit different. I like the backpack because I can't overload it with a bunch of stuff, and allows me to get up through hatches going up onto roofs. If I have a side bag, sometimes it's a little bit more difficult. And you guys can customize your bag depending on what tools you need and what's going to work best for you. Just a bunch of different nut drivers. I've got the hollow shaft. You want hollow shaft. If you want magnetic, you can get magnetic, but definitely you need hollow shaft. Otherwise, you're going to bottom out before you can ever hit the nut. I've got a set of just some tin, snips, aviation snips in here. Pipe wrench, just a small little pipe wrench in here. This is a nice little tool. You don't necessarily need this, but I definitely like it. This is just a ratcheting crimper. So when we're going and making our male and female spaded connections, we can go ahead and ratchet our crimps nice and tight. This works really well. I've got like a little pack of just wire nuts, screws, connectors, all inside there. Things that, instead of me running all the way to the van to get something, just got a small pack. Razor blade. You're going to need some Allen wrenches from time to time, open up certain things. Getting into little tight spots, you can use a little 90-degree. Put this on your drill, get right in there. You want a small little level, leveling out electrical boxes, thermometers, any of that sort of thing. Got a little a lighter in here and a larger pipe wrench. And then if we open up the front pouch, got some thermometers. You want two. The reason being is you're going to have a temperature difference between the two. So I'm going to measure the intake and the return and the supply temps. Get the difference between the two. It's easier just if you have two guys. I like these because they're bendable. I'm going to put them into the supply or the return, and then the little magnet's going to sit right there. So it'll give me a direct reading. Attach it right to the duct, and it's going to stay. Otherwise, if I put it in, this probe is going to sit inside the duct, and it's just sort of going to hang. So I like these ones that bend. Got a pocket psychrometer. We're doing AC work. We're going to want to know what our wet bulb, dry bulb is. That's what this guy does. So I've got these guys. Malco makes these really nice because this is a 1/4 inch driver. So we have a lot of 1/4 inch screws that we're going to be dealing with, 1/4 inch heads, and then we have 5/16. So all you do, if I can, these are held on by magnets. Can't do this one-handed, so hold on. So all you do is you remove it, and if you have any debris on the end, you can clean the debris, metal shavings, so that are inhibiting how inhibiting your screws from getting all the way in. You can flip it, set it in place, and now all of a sudden, I can do 1/4 inch, or I can reverse it and do 5/16, all with the same tool. So they do come in a little bit longer lengths. They don't have these little, they have the stubby guys. They have, I think, up to 6 or 8 inches, so really nice. We've got a little flame sensor, just cleans it up nice and neat. We don't want to use sandpaper. Sandpaper actually will clog up the pores of the flame sensor, causing it to wear out prematurely. My little little trick for you guys is these little Husky ratcheting wrenches. Home Depot sells them. Real nice, because sometimes I have a tight little spot and I need to ratchet something in there. This works out really well. What else do I got in here that I can show you? Obviously, nice little magnet guy. The old switcheroo. If I'm working on a system and I've got the door off while there's a door safety switch, that door safety switch needs to be depressed for the system to run. I can bypass that, or I can use this little magnet, plop it on the switch, and it's going to hold it in place, so I can safely work on the system without having to hold it while I'm doing things. And of course, I've got my service wrench. Need a service wrench, and there is this piece right here. So if I'm working on a system and I need to open or close the service valve, that's what I use. I use my service wrench. It's got the Allen heads right on attached to it, and obviously goes both ways. So of course I forgot, we're gonna need a scale. So I've got these Field Piece wireless scale. It's cool. Put my refrigerant up on top. It'll give me my readout digitally right here, and I'm set. So if I need to, I can hang my little display somewhere so I'm not attached. I can go far away, take it with me, whatever range that is, and work on something else if I need to. So that's it with the tools. All right, so hopefully you guys like this little video. Showed you a few things that you may use, may not need. Oh, I do have one more thing to show you guys here really quick. Right there, that's a bandsaw. Awesome tool if you're going to be doing electrical conduit, things like that. I've used that thing so many times. It cuts through steel like butter. Just watch out for your fingers, obviously. But so those are the tools that I use. I have in my van. All right, guys, I know it was a little bit of a longer video there, but I think it went into detail quite well. Different tools, things that I use over the course of my career here. So but anyways, that's it for today. Make sure you guys get the assignments done. We'll do one more class next week, and I think then we've got a spring break.